what they are. They are shell, no? Inside air will be there. Agreed this? So all these are balloon. Balloon will not be spherical in shape, so I'll not give example of balloon. Basketball, volleyball, they are good examples. So what about the field due to them? So the thin spherical shell. We need diagram. I'll draw it here. It's a thin. Mass m. So here for your understanding purpose, I'll write air, this air. So let it be made up of iron or rubber, anything you can take it. Usually we discuss the rigid one, let it be iron, that one. So able to understand now what do you mean by thin spherical shell or hollow sphere, both are same. Now what is the field strength at this particular point, at point P1, where the point P1 will lie outside this. Now strictly what is R? R is greater than capital R. Now first E bar outside the thin shell. Shall we assume again Gaussian surface? Again, after assuming a Gaussian surface, then the whole shell will appear like a point by any reason, because it's also distributed symmetrically. So what is that Gaussian surface? The Gaussian surface will be like this. I'll show. I think we'll wind up here only, everything. There's a Gaussian surface, and this is what that shell. And this is the radius R. Now what is that red color dotted line? Gaussian surface, and this is what that shell. Agree this? So where is our point P1? It lies here. Then again what we are going to assume a surface on the Gaussian surface. N cap will come like this. E1 will come. E1 or E out, anything you can. Let me write E1 in this case. Then what is the formula? There's everything will appear like a point mass, no? You can treat like a point mass because symmetrical distribution. So or the formula will be E1 bar dot ds. Now what is the net mass enclosed? The mass of the shell. And where do it appear? It will appear like a point mass. Then at all points E1 is constant on Gaussian surface. So integral of ds cos of. So this will become, what is the integral of ds will be 4 pi r square. So strictly R greater than capital R. So what is the gravitational coefficient outside the thin shell? It is equal to this much here, gm by r square. So shell solid sphere same. Yes, we got the answer like that. Now on the surface, E outside the surface, E1, no? And this is E2. On the surface, I'll write E2 is equal to gm by r square, where r equal to capital R. What about inside? Because where mass is present only at a distance capital R, not like solid sphere. Basketball, where that rubber will be there. Elastic, I think, shall I call elastic material? For basketball, where elastic material will be there? Only on the surface, no? That is. What about inside? Inside everything will be air or hollow. So I'll draw the shell. Now let's draw the Gaussian surface. See, what is maximum? Our physics approach is such that we will avoid mathematics, because mathematics, it's a tool. That's all. It's not a concept. See, that's why Students nowadays are focusing more on math-based problem. You look at the advanced, no? Hardly will get a question where there is integration. You check from 2015 to 2020. At the most, past 5 years, question paper advance. I think 10 question papers will get every year, two papers, paper one, paper two. There are hardly 3 or 4 questions which are there on integration differentiation. The rest all everything all basic laws. But I am very sure what type of questions you do like more math based because you are good in maths. So what you are good is doesn't like what is good for exam is what you have to prepare. Are you getting my idea? I'm not against the mathematics, but I really want you to do the mixed concept problems more because the type of exam what you are writing doesn't need much mathematics. That's what I feel. See the type of see finally what is your goal? Advanced good rank. That's all. No. So in advance you check it. No, but we should know good mathematics. It's not that we should avoid integration. We should know how to use the mathematics. It's not that everything is maths. Please don't take it in another way. So now, sir, okay, thank you very much. Any integration problem, I'll skip it. You'll never understand anything in physics. But sir, what you should do? You should give focus first, say learning concepts. Okay, do integration based problem, and 5% of problems on based on integration difference. Remaining all mixed concepts. Mixed concept means what? Work-Ng theorem, friction and gravitation, rolling motion and gravitation, projectile motion and gravitation. Yes, bring it. Different ideas. They will help you a lot in exam. So I do like students to take that challenging type of question, mixed concepts, rather than confining only to integration based. See, anybody can say mass. No, what is a mass? Procedure. If you know procedure, finish over. What is there in that one? So solving problem, I think calculations had to be not given that much of highest priority. There's a dotted, no? I have to show it. Everything I'm keeping in mind. Second year one topic electrostatics, Gauss law. I'm focusing here. Okay, fine. So there I think within one day we can wind up Gauss law. 1 week they're given. Within one day we can wind up. And this is a Gaussian surface. This is the shell where the mass is present. The mass is m here, and this is a Gaussian surface. Now you see this. This is a point P3. No, tell me now, what is the net mass enclosed by the Gaussian surface? Zero. No, there's no mass here. But sir, like a mass is present here. Again, the same thing. This mass, so you shade like this. Just this idea, just only to make students to think. I'm describing things like this here. What mass is contributed by this region? No, what field is contributed by the region one? I think it's not a arc. Am I right? It's a shell. No. So what do you get? You get some sort of a cap. Shall I call? What mass, what field contributed by the spherical cap, by the cap one, the same field will be equal and opposite field will be contributed by the spherical cap two. All of you, cap means if you take a sphere, if you cut like this here, it will become hemisphere. If you cut it here, this will become cap. If you take a spherical shell, okay, this is called as a cap. Spherical cap it is called as. So I think similarly what we get it here, no? There's a one cap, spherical cap one. There's a spherical cap two. Where the center will be here only. The field contributed to spherical cap one and two will be equal and opposite. The net field will be zero. This is one mathematical way, or according to Gauss law, where the net mass enclosed by the Gaussian surface zero. E3 bar dot ds 4 pi g. So there's no problem. So just LHS leave like this. This is 0. As ds will be non-zero. You take any surface here, elemental surface. There will be elemental surface, no? There's no problem with elemental surface. Am I right? There's no problem with the elemental surface. We do have. But what is 0 here? There's no field. That's why, since M enclosed is 0, therefore ET should be 0. Don't write ds 0. Gaussian surface, you assume, no? So what is the surface of a Gaussian sphere? 4 pi r square. Agree this one? So like this, what happened? What is the field inside the shell will be 0. Means everywhere inside the field will be 0 inside the shell. So if you draw a shell, what about the field at A, B, O, C? I'm picking up some arbitrary points. What the field? EA, EB, EC, everything will be 0. Agree this? This one? What about on the surface? As gm by r square. Outside, gm by smaller, similar to solid sphere. So if you are interested, so sir, how to find out mathematically by integration? What you should do? You should assume a ring here. You should assume a ring. Then due to this ring, what is the field at point P1? Elemental ring. Then integrate, you'll get the total field. If you want to try, if you have a time, sufficient time, you can try that one. I think I'll wind up. 8:10 it is.